12 cancer risks of poor sleep most people ignore. Sleep problems are widespread globally, with roughly 1 in 3 U.S. adults not getting enough sleep, impacting around 70 million Americans, while worldwide over a third of adults report insomnia and many experience poor sleep quality, highlighting a significant public health concern. You can eat clean, exercise daily, and avoid every obvious toxin. Yet one silent habit may still be working against you every night. Poor sleep is no longer just about feeling tired or unfocused. Medical research now shows it can quietly reprogram your biology in ways that promote cancer growth, progression, and even recurrence. What makes this dangerous is that most people think a few bad nights don't matter. But inside your body, those nights are sending powerful signals to your cells, signals that cancer knows how to exploit. Melatonin is not just a sleep hormone. It is one of the body's strongest natural anti-cancer defenses. It suppresses tumor growth, enhances DNA repair, reduces estrogen production, and neutralizes oxidative damage. Artificial light at night, screen exposure, and late bedtimes dramatically suppress melatonin release. When melatonin drops, cancer protective signaling weakens across multiple tissues. This is especially linked to higher risks of breast, prostate, and colorectal cancers. Poor sleep quietly removes one of your most powerful nightly defense systems. Your sleep-wake cycle controls critical clock genes that regulate when cells divide and repair themselves. Genes like PER, clock, and BMAL1 act as cellular traffic lights, preventing uncontrolled growth. Chronic sleep disruption silences these protective signals. When circadian genes fall out of sync, DNA replication errors increase. Cells divide at the wrong time, under the wrong conditions. This genomic instability is a foundational step in cancer development. Sleep deprivation alters hormone regulation, particularly estrogen and progesterone balance. Even moderate sleep loss can raise circulating estrogen levels. Elevated estrogen fuels hormone-sensitive cancers, such as breast and endometrial cancer. At the same time, natural anti-proliferative signals are reduced. Hormones begin stimulating growth when they should be resting. Over time, this hormonal misfire increases cancer risk significantly. If this information is eye-opening, take a moment to like this video and subscribe to the channel. What you're learning here could change how you protect your health every night. Deep sleep is when your immune system actively hunts abnormal and precancerous cells. Natural killer cells are activated, damaged cells are cleared, and immune surveillance peaks. Poor sleep can reduce NK cell activity by up to 70%. That means fewer cancer cells are detected and destroyed. The immune system becomes less precise and more fatigued. Cancer benefits when nighttime immune repair is compromised. Chronic sleep loss drives systemic inflammation throughout the body. Inflammatory markers like CRP, IL-6, and TNF-alpha remain elevated. This inflammatory environment damages DNA and promotes tumor growth. Oxidative stress accumulates faster than the body can repair it. Cancer thrives in tissues that are inflamed and oxidatively stressed. Poor sleep quietly sustains this dangerous internal environment. And here's the part most people never hear. Sleep doesn't just affect cancer risk before disease begins. It can determine how aggressively cancer behaves and how well the body can fight it once it appears. Just a few nights of poor sleep can induce insulin resistance. Blood glucose rises, insulin spikes, and IGF-1 signaling increases. These signals directly stimulate cancer cell growth. Cancer cells thrive on excess glucose and insulin-driven proliferation. This pathway strongly links poor sleep to pancreatic, colorectal, and breast cancers. Sleep loss effectively feeds cancer at the metabolic level. Undiagnosed sleep apnea causes repeated drops in oxygen during sleep. This intermittent hypoxia activates pathways that promote angiogenesis, allowing tumors to build blood supply. Hypoxia also increases tumor aggressiveness and metastatic potential. Cancer cells adapt well to low oxygen environments. Studies show higher cancer mortality in patients with untreated sleep apnea. This risk often goes unnoticed for years. Healthy sleep requires cortisol levels to fall sharply at night, allowing the body to shift from stress response into repair mode. Poor or fragmented sleep prevents this drop, keeping cortisol elevated when it should be biologically quiet. Persistently high nighttime cortisol suppresses immune repair, weakens natural killer cell activity, and enhances survival signaling in abnormal cells. It also interferes with melatonin release, further stripping away anti-cancer protection. When stress hormones remain chronically activated, tissues stay locked in a low-grade fight-or-flight state. Cancer exploits this hormonal imbalance because stressed cells are less capable of self-correction and elimination. DNA repair enzymes are most active during deep, uninterrupted sleep, when cellular energy can be fully allocated to maintenance. Fragmented or shortened sleep delays the repair of DNA strand breaks caused by oxidative stress, inflammation, and environmental toxins. As damage persists, mutations are more likely to be copied during cell division instead of corrected. Over time, chromosomal instability increases, disrupting normal cell cycle control. Faulty cells that should be repaired or destroyed are allowed to survive. This breakdown in nighttime DNA maintenance creates ideal biological conditions for cancer initiation and progression. In cancer survivors, poor sleep is consistently linked to higher recurrence rates and shorter disease-free survival. When sleep quality is low, disease progression tends to accelerate and remission becomes less stable. Treatment tolerance also declines, limiting the effectiveness of chemotherapy, radiation, and immunotherapy. Sleep deprivation disrupts immune surveillance and hormonal regulation that help keep residual cancer cells dormant. Because of this, sleep quality is now recognized as a prognostic factor in oncology. Survivorship outcomes depend heavily on restorative sleep long after treatment ends. Recovery does not end when treatment ends. It continues every night. During deep sleep, the body activates critical tumor suppressor pathways designed to halt abnormal cell growth. Proteins such as p53 and BRCA detect DNA damage and either repair it or trigger cell death. Sleep deprivation downregulates these protective mechanisms, allowing damaged cells to escape control. Instead of undergoing apoptosis, abnormal cells survive and continue dividing. DNA errors persist and accumulate across cell generations. This breakdown in tumor suppression is a foundational step toward malignancy. Sleep activates the glymphatic system, which clears metabolic waste and oxidative byproducts from tissues. When sleep is poor, this clearance system slows dramatically. Carcinogenic metabolites and reactive oxygen species accumulate within cells. As oxidative stress increases, DNA strand breaks become more frequent. Mitochondria suffer repeated oxidative injury, impairing cellular energy regulation. Cancer risk rises steadily as cellular toxicity builds night after night. Cancer is closely linked to metabolic dysfunction at the cellular level. During sleep, mitochondria undergo repair, recycling, and biogenesis to maintain energy efficiency. Chronic sleep loss damages these processes, leading to mitochondrial dysfunction. Cells shift toward glycolysis, a metabolic state cancer cells prefer for rapid growth. Lactate production increases, acidifying the tissue environment. This metabolic reprogramming supports tumor survival and expansion. Poor sleep quietly reshapes cellular energy systems in cancer's favor. Each night, the immune system actively edits and eliminates precancerous cells. Natural killer cells and cytotoxic T cells identify abnormal cells before they become dangerous. Sleep deprivation exhausts these immune cells and weakens their killing capacity. Immune tolerance toward abnormal cells increases instead of decreasing. Early malignancies escape detection and remain hidden. Cancer survives longer and grows quietly when immune precision is lost. Sleep is essential for accurate immune surveillance. Sleep loss alters gene expression without changing the DNA sequence itself. Epigenetic mechanisms, such as DNA methylation and histone modification, become disrupted. Tumor suppressor genes may be silenced, while oncogenes become more active. These changes can persist even after sleep patterns improve. Cancer vulnerability becomes embedded at a molecular level. Poor sleep leaves a lasting biological imprint that extends far beyond fatigue. Even without diagnosed sleep apnea, fragmented sleep reduces oxygen delivery efficiency at the cellular level. Hypoxia-inducible factors such as HIF-1A become activated under these conditions. This signaling promotes angiogenesis, allowing abnormal tissue to build new blood supply. Cancer cells adapt quickly to hypoxic environments and become more invasive. Tumor aggressiveness increases as oxygen imbalance persists. This silent hypoxia fuels malignancy without obvious symptoms. Sleep plays a critical role in regulating autophagy, the process that removes damaged cells and organelles. Poor sleep disrupts this cellular cleanup system. Defective proteins and dysfunctional mitochondria accumulate instead of being recycled. Precancerous cells that should be eliminated are allowed to survive. Cellular waste builds and interferes with normal signaling. Autophagy failure removes an important barrier against cancer progression. Sleep disruption significantly reshapes the gut microbiome. Beneficial bacteria decline while inflammatory species increase. Intestinal permeability rises, allowing bacterial toxins to leak into circulation. This triggers systemic inflammation and immune dysregulation. The gut immune cancer axis plays a central role in tumor biology. Poor sleep destabilizes this communication network, promoting chronic inflammation that supports cancer growth. Cancer risk is influenced not only by hormone levels, but by when those hormones are released. Poor sleep disrupts circadian timing of estrogen, testosterone, and growth hormone. Hormones are released at biologically inappropriate times, sending mixed growth signals to cells. Protective nocturnal hormone pulses are reduced or lost. This mistiming stimulates abnormal cell proliferation. Circadian misalignment creates hormonal chaos that cancer can exploit. Sleep deprivation reduces the effectiveness of cancer treatments at the cellular level. DNA damage response to radiation therapy weakens when circadian timing is disrupted. Immunotherapy becomes less precise as immune coordination declines. Chemotherapy toxicity increases while therapeutic benefit decreases. Cells are treated at suboptimal biological times. Sleep quality directly influences how well treatments work and how well patients tolerate them. Cancer stem cells are responsible for recurrence, metastasis, and treatment resistance. Sleep disruption activates signaling pathways such as WNT, Notch, and V-catenin that protect these cells. As a result, cancer stem cells become more resilient and harder to eliminate. Conventional treatments may shrink tumors while leaving these cells intact. Tumors then regrow more aggressively. Poor sleep unintentionally shields the most dangerous cancer cells. Poor sleep can reactivate dormant cancer cells years after apparent remission. Angiogenic switching allows tumors to rebuild blood supply and resume growth. Immune containment weakens gradually over time. Recurrence may occur long after treatment is considered successful. Sleep quality plays a critical role in long-term survival. The biological risk does not end when treatment does. It continues every night. If this video helped you understand how deeply sleep affects cancer risk, like this video and subscribe to the channel if you haven't already. Sleep is not passive. It is one of the most powerful biological defenses you have.